Hello viewers, welcome to the eMath learning platform by Peter Ikaja once again. I am now going to take you through the continuation of the O-level probability. And for today's case, we shall basically look at probability tree diagrams. My YouTube channel still remains the same, and make sure you go visit it, subscribe to keep receiving updates whenever I upload new content. My contact details and the email address are also here below. Now let's go direct to probability tree diagrams. Now in probability tree diagrams, we shall always look at two ways of selection. That is to say, selection without replacement and the selection with replacement. For today, we are basically going to begin with the selection without replacement. Now, we are going to go direct to sample questions and understand more on how we can actually do a selection but without replacement. Now, we have question 1 here. A box contains 5 black balls and 3 red balls. 2 balls are picked at random, one after the other, without replacement. Find the probability that Roman 1, both balls are red, and Roman 2, both balls are black. Roman 3, one ball is black and one is red. Let's look at the solution for this. Now, we are simply going to draw a tree diagram that looks like this. But to explain this briefly, it is kind of simple because they told us there are 5 black balls and 3 red balls. Now, what are we going to do? We always have a given number of pickings right from the question. Like, for example, here they say 2 balls are picked. It means we are going to have 2 pickings. If they say 1 ball, then you only go for 1 picking. If they say 3 balls, then you have to continue for the 3rd picking. For this case, we have the 1st picking and the 2nd picking. But elaborate more about the 1st picking. Remember, there are 5 black and 3 red. But if you get the sum of the 2 colors, it gives you a total of 8 balls. So it means in the 1st picking, the probability of getting black 1 will be this 5 out of the total, which is 8. Automatically, this will be 3 out of 8. Now remember, for probability tree diagrams, when you sum the probabilities of a junction, they should add up to 1. That is something very important that you should not forget. So what does this mean in this case? When I go through this arm, it means I have picked a black ball, but I have not picked the red. So the red remains the same, but the black balls reduced by 1 because I've already picked 1. So at this point, again, it means I am picking a black ball, and in this case, I am picking a red ball. But I am saying probability of B2 because we are in the 2nd picking, and probability of R2 because we are also in the 2nd picking. Then when you come to this arm here, it means you are actually picking the red ball, but you are not picking the black one. So the black balls will remain the same, but the red balls will reduce by 1. Then from here, again, you find out the total. 5 plus 2 will be 7. So the probability of B2, because of the 2nd picking, will be 5 out of the total. And automatically, this will be 2 out of the total. So that is how we get 5 out of 7 and 2 out of 7. Now, for simplicity, I tried summarizing this information for you, but how did I obtain it? Now, when I pass through this arm here, I will have B1. Continue to this, B2. So it means I'll have probability of B1 intersection B2. When I pass through the same arm, then come and branch into this, I will have B1 and R2. That is how I obtain this. When I pass through this R1 and B2, I will have probability of R1 intersection B2. And the same thing happens when I pass through this and this, which gives me R1 and R1. So B1 means only black balls, all the 2. In this case, R1 intersection R2 means there are 2 red balls. This case means one black ball and one red ball. One red ball and one black ball. So that is how we interpret or draw a probability tree diagram. Now to answer the questions, Roman 1 says both balls are red. Now if you want both balls red, just simply look for where we have R1 intersection R2. But before you reach here, remember we passed through this and this. So it will be 3 out of 8 multiplied by 2 out of 7. Why do we multiply them? Because the two events are actually independent. So that is how we shall answer that part of the question. So we are saying probability that both balls are red will be probability of R1 intersection R2. So we have substituted their values, and if you multiply 3 by 2 you get 6 out of 56, and if you divide through by 2 you will get 3 out of 28. Roman 2 wanted both balls being black. Still, when you go back to our probability tree diagram, if you only want black, we shall have black 1 and black 2. So it means we shall have 5 out of 8 and 4 out of 7. That is what we shall have to multiply. So that is how this came about. 5 out of 8 times 4 out of 7, which gives us 20 out of 56, and if you reduce it, it gives you 5 out of 14. Roman 3. Now Roman 3 states that we get the probability of one black and one red. But still, when you go back to your tree diagram, to get one black and one red, you're going to realize that we are either going to take this, we have a black one here and a red, but we also have a red one and a black. So as long as we have one of each colors, then we take that choice. So it means we're going to take both choices, this and this together. So it means to get this, we shall get 5 out of 8 multiplied by 3 out of 7. To get this one here, we shall get 3 out of 8 multiplied by 5 out of 7. That is basically what we shall do in Roman 3. So we have clearly stated that. Then after, you simply multiply them, add them correctly, and when you do everything rightly with a calculator, you will come up with 15 out of 28. That will be our number 1. Let's look at number 2 now. Number 2 says a box contains red 4 pens. This should be corrected. Let us correct that. So it's supposed to be 4 red pens and 6 black pens. Now 2 pens are randomly picked without replacement. Find the probability that Roman 1 or part A, both are red. Part B, they are of different colors, and part C, at least one red pen was picked. Let's look at the solution for this. Now, we have 4 red. We have 4 red and 6 black. Now, to pick the red one in the first picking, the probability will be 4 out of 10. And to pick the black one in the first picking, it will be 6 out of 10. As I hope you can see this, you just simply get 4 divided by the total, then get 6 divided by the total of the 2 colors. That is how we got this. And remember, we said when you go through this arm, it means you've only picked the red ball. I mean the red pen in this case, because I think our question was talking about pens. So if you've gone through this route, we have clearly said that it is the red pens that reduce by 1, but the black ones will remain the same. So that is why you see I have 3 here and I have 6. So to get the probability of red 2, because we're in the second picking, it will simply be 3 out of the total, which is 9. Then to get the one of black 2, it will be 6 out of the total, which is also 9. Then do the same here. For this case, it means we're now picking black and we are not picking red. So it means the red is supposed to remain the same. That is why you see a 4 here. So we have 4R, meaning for red. But the black ones have reduced by 1. That is why you see 5. Then again, to pick a red, because we are in the second picking, probability of red 2 will be 4 out of the total, which is 9. And this probability will be 5 out of the total, which is also 9. So that gives us our probability tree diagram. Now let's try to answer the questions. Part A wanted probability that both of the pens are red. Now both red means R1 and R1. So you simply pick 4 out of 10 multiplied by 3 out of 9, which we have here clearly giving you 12 out of 90, which can be simplified by 6 to give you 2 out of 15. So that becomes our answer for part A. Let's look at part B. Probability that they are different colors. Different colors means if you have red, then you should have it with black. For example, this is okay. We can also have black and red. So it means we're going to take the two options. And if you try to, like for example here, you want to get probability of red 1 intersection B2, I simply come to red 1, which is 4 out of 10, multiplied by B2, which is 6 out of 9. Come to B1 intersection R2, come to B1, take 6 out of 10, multiplied by R2, which is here 4 out of 9. And that gives you the probability of different colors. So when you substitute your values correctly, multiply them correctly, and add them correctly, you will come up with 48 out of 90, which can be simplified to 8 out of 15. That is by dividing through by 6. So that gives us part B of the question. Let's look at part C. Part C of the question. What does part C want? Part C says at least one red pen. Now, when we say at least one red pen, like we said in question 1, it means either one red pen or more. But remember, we are picking a maximum of 2 pens. So we are either going to pick one red pen, and we can also pick all the 2 red pens. But picking one red pen in this case means you pick one red and automatically the other should be black. That is why you see we are saying a red 1 intersection black 2. Wherever you have a red, then the other should be black. Then also this, I see black, but this should be red. So I have one red here, I have one red here, but I can also have all the 2 being red. That is what we mean by the word at least. You have to take it with care and take it seriously. So from that point, you simply go back to your tree diagram. You pick the probabilities of R1 intersection R2, R1 intersection B2, and B1 intersection R2. If you do it correctly, you will come up with all this. And if you multiply correctly and you add, you will come up with 60 out of 90, which can be simplified to 2 out of 3 by dividing through by what? By 30. So that brings us to the end of number 2. Now let's try out this exercise. Make sure you try it out. The answers are clearly quoted for you. And in case of any challenge, you feel free to consult. So this is our exercise. And with that, I believe I have all reasons to say thank you so much and may God bless you.